Hello again. In this video, we're going to look at 4 different concentration problems so you can see how to do each of the different permutations of the concentration problems. We're going to be focusing on 112, 118, 121, and 128 in page 390 in your textbook. So let's look at 112. 112 reads, a patient's blood test shows that he has a bilirubin level of 0.012 moles per liter. How many moles of bilirubin are there in 5 mils of her blood? It's kind of interesting. It's a he and then a she, so we'll just go with the values and not worry about the potential gender errors in this problem. All right, so what do we know? We know that the 0.012 moles per liter, the test 0.012 moles per liter. Okay, moles per liter we know is molarity, so this is 0.012 molar. And we are looking for moles of bilirubin in 5 milliliters of blood. Not 0.05. Let's fix that. 5.0 milliliters of blood. Okay, so I'll write bilirubin small b capital R, and we're looking for 5 mil sample. So how many moles? Well, molarity equals moles of solute per liter of solution. All right, well, we have a molarity here, so we can plug that into the molarity. We have a volume here, and then we'll get moles. So let's plug in here 0.012 moles per liter. We're looking for moles, and we have a 5 mil sample that we want to look for. We need this in liters though. We do that. 0.005 liters. It helps if you could see my decimal point. All right, getting moles by itself, we're going to take this and multiply it by both sides. Now we have liters on top, liters on the bottom, moles equals moles, so that's great. We do this math, and we get, we're limited by 1 sig fig here, and that's good because that's what we get anyway. 6 times 10 to the minus 5 moles. There's 6 times 10 to the minus 5 moles of bilirubin in 5 milliliters of blood sample. All right, let's look at the next one, 118, on the same page. 118 reads, how many moles of calcium ions are there in 0.52 liters of 0.45 molar calcium chloride? All right, so we have a solution of calcium chloride. We have a 0.45 molar, okay, so 0.45 molar solution. And we're looking at a 0.52 liters of it. 52 liters of that 0.45 molar solution. So again, molarity equals moles per liter solution. Okay, so we have molarity, we have the volume, we solve for moles. Remember, molarity is moles per liter. We're going to be solving for moles. We have this in liters already, so that's really nice. 2 sig figs, we need to multiply both sides by 0.52 liters. All right, so 0.52 multiplied by 0.45 equals 0.234 moles. We need to reduce it to 2 sig figs, so this is going to be 0.23 moles. Now, we need to make sure we have it right with equivalence, because calcium in this, we have 2 Cl's and 1 Ca. When this dissolves, it breaks up into its constituent ions. We have 2 Cl minuses and we have 1 Ca plus 2. In this case, since each molecule is just going to give us 1 calcium ion, we don't need to change this around at all. This is already correct, so we're good. If this was asking for the concentration of chlorine, we would need to double this, because for every molecule of calcium chloride, it's going to pump out 2 chloride ions. So it would be double that concentration, but not in this particular case. All right, let's look at the next one. That would be 121. 121 reads, how many equivalents per liter of sulfate ion, SO4-2, are there in a 0.15 molar solution of MgSO4? All right, so we have a 0.15 molar solution of MgSO4. Thinking about this, Mg is going to be +2, SO4 is going to be -2. So every time this molecule dissolves in water, it's going to break up into 1 magnesium ion and 1 sulfate polyatomic ion. All right, so 121. And let's see, how many equivalents per liter sulfate ion are there in 0.15 molar solution? Okay, so basically we just need to remember what equivalents are. So looking at this, we have Mg, SO4. Every time this goes into water, we're dissolving it. We're getting Mg +2 plus SO4 -2. All right, and this is per mole. This is aqueous. Remember, it's dissolving. All right. Now, if we have 0.15 moles of MgSO4 for every liter solution, that means we're going to have 0.15 moles of Mg +2 for every liter solution, right? And since it is +2, it is going to be 2 equivalents. For every mole of Mg +2. So moles of Mg +2, moles of Mg +2, and we're going to get equivalents of Mg +2. So 0.15 times 2 is going to give us 0.30 equivalents of Mg for every liter. Oh, I just moved to an eraser, and that's not going to help us do this problem. All right, so 0.30 equivalents of Mg +2 for every liter. If this question was asking about sulfate, it would be the same thing. Sulfate has a charge of -2, so it would still be 2 equivalents of a sulfate for every mole, and that would give us the 0.3 as well. Finally, let's look at 128. 128, and that reads, an order is given for 50 milligrams. Let's write this down. 50 milligrams of Vistaril, an antihistamine, to be administered every 3 hours. All right, so let's get Vistaril here. Vistaril. So every 3 hours. Okay, the suspension contains 25 milligrams for every 5 mils. 25 milligrams for every 5 milliliters. What volume of the suspension in milliliters should be administered to the patient every 3 hours? Okay, every 3 hours. So we're looking for 50 milligrams of Vistaril for every 3 hours, and the suspension is 25 milligrams for every 5 milliliters. Okay, so dosage, 50 milligrams every 3 hours, but we have what? We have 25 milligrams for every 5 milliliters. Now, remember, this is just dimensional analysis. Milligrams on top, hours on the bottom. We need this in what? The answer needs to be volume, right? All right, so we need this in milliliters per every 3 hours. So hours need to stay. Milligrams we're going to need to get rid of. If we put milligrams on top here, it's going to be milligrams squared. So we need something milligrams there on the bottom. And we need milliliters on top here. All right, so now we look at our suspension, 25 milligrams for every 5 milliliters. All right. When we multiply this out, milligrams are going to cancel. We're going to be left with milliliters per hour. So this is set up correctly. Remember, if we put the 25 milligrams up here, it's going to be milligrams squared, and that's not helping us one bit. Pay attention to what the problem is asking for units, and then you can set up your proportionality in the dimensional analysis correctly. All right, so 50 times 5, or we can actually just, depending on how you want to do it, we can do the math, or we can reduce it down. So this is 50 over 15, okay? And if we do this math here, 15 divided by 50, I obviously just did something wrong. Yes, I did. Let's erase this. I'm not multiplying it by the 3 hours, you see? Even I can make a mistake. It happens. So 1 to 5, we reduce this down. 5 goes into this 10, so it ends up being 10 milliliters for every 3 hours. I was multiplying by the 3 hours, but we didn't need to do that. All right, so 10 milliliters. Or you could have avoided the problem or avoided the math altogether, and you could have said, all right, well, I need 50 milligrams. Every 5 mils is 25 milligrams, so I need twice this. So twice 5 mils is 10 mils. The math ends up being pretty easy, so this ends up being the 10 mils of the sample. You can do it just headstrong, or you can work it out dimensional analysis wise. So those are your 4 problems. Hopefully this will help you go through the concentration questions.